Hi, this is ECAA 2017 question 30. So for this question, a company has a total of 180 employees. So we have 94 category P employees and 86 category Q employees. And all of these employees were asked how they travel to work each morning. And responses have not yet been received by everyone, but the ones that we have received are shown in this table here. So they could either have walked or cycled, gone in the car, or some other means of transportation. And when all the responses have been received, an employee will be chosen at random from those who travel by car, so out of these ones. And then we'll calculate the probability that this employee is from category Q. And the question is, what is the smallest this probability can take? Alright, so the probability that the employee we pick out of the ones who travel by car is from category Q is going to be the number of employees from category Q who travel by car divided by the total number of employees who travel by car. So if we want this to be as small as possible, this probability, then we're going to want the numerator to be as small as possible, and we're going to want the denominator to be as large as possible. So basically we want a lot of people to be travelling by car, and we don't want many of them to be from category Q. So we're going to want as many of these people who haven't responded to be in category P and travelling by car as possible. So let's work out how many category P and category Q employees have responded already. Alright, the number of responses from category P, I've just summed up all the numbers in the category P row. So that's going to be equal to 75. And for category Q, so just summing up this category Q row, we see that we've had 78 responses from category Q employees. And we were told that there are 94 category P employees in total and 86 category Q employees. So that means we're going to have 94 minus 75 category P employees who haven't responded. So that makes 19 category P employees who haven't responded. And for category Q, we're going to have 86 minus 78 employees who haven't responded. So that gives us 8 category Q employees that have not responded. Okay, so we've got 19 category P employees to put somewhere in this table. And remember we said we wanted as many category P employees travelling by car as possible. So I think it's pretty obvious we're going to put all 19 of them in here. So that's going to give us 31 category P employees travelling by car. And now we have to decide what we want to do with these 8 category Q employees. So we have to choose either to minimize the numerator or to maximize the denominator. So first of all, if we're minimizing the numerator, then we want to keep this number as small as possible. So we'll put these 8 category Q employees into either walk or cycle or other, so that we don't increase this number. So that means our probability is going to be, we still have 21 category Q employees here, so 21 in the numerator, and then the total number of employees is going to be 21 plus 31, so that's 21 over 52 as our probability. And now if we're going to maximize the denominator instead, then we'll put all 8 of these employees into here, so that we have as many people travelling by car as possible. So that means we'll have 29 category Q employees travelling by car. So for our probability, that means that we'll have 29 in the numerator for the number of category Q employees and 29 plus 31 for the total number of employees. So that gives us 29 over 60 as our probability if we chose to maximize the denominator. Alright, so now we just have to decide which one of these fractions is smaller. So you could multiply everything out and put them both over a common denominator. but then you'd have to multiply some pretty big numbers, and I'm too lazy to do that, so I'm going to do this slightly differently. So I'm going to write this as 26 over 52 minus 5 over 52, which is equal to a half minus 5 over 52. And for this one, I'm also going to do the same thing. So it's 30 over 60 minus 1 over 60. So again, a half minus 1 over 60. So now we've rewritten them both as a half minus something. So the smaller fraction is just going to be the one where we're taking the bigger thing off. So if we can find which one of these fractions is bigger, then that's the one that's got the smaller fraction and the smaller probability. And I think it's fairly obvious that 5 over 52 is going to be bigger than 1 over 60, because we have both a larger numerator and a smaller denominator. So here, because we're taking something larger off, that means that this fraction is smaller, so 21 over 52 is going to be smaller than 29 over 60. So the smallest probability is 21 over 52, i.e. solution B.